Mountain of Roses, everyone. I am Kimberly Castillo from BSIT 1A. Today I'm going to demonstrate the 4 pillars of object-oriented programming. These pillars are encapsulation, inheritance, polymorphism, and abstraction. Let's create a class that is called worker. A class is like a blueprint or template for creating objects. It defines attributes and methods that describe an object. The first OOP pillar is encapsulation, which means hiding data and only allowing access through controlled methods. This is a constructor to initialize object attributes and a public method to display data. And this code is encapsulation, protects our data by preventing direct modification from outside the class, ensuring data security and integrity. Now, let's move on to the second pillar of OOP, which is inheritance. This allows us to reuse properties and methods from one class in another. Let's create a new class called engineer that inherits from worker. This means engineer will automatically have all the attributes and methods of worker without having to rewrite them. Now, engineer inherits everything from worker, so we don't have to redefine display. This reduces code duplication and makes our code more efficient and maintainable. The third pillar of OOP is polymorphism, which means one function can behave differently depending on the object calling it. To achieve this, we use virtual function in the base class and override them in the derived class. Since rule function is virtual, if we call it using a base class reference or pointer, the overridden function in engineer will be executed instead of the base class function. Now, finally, let's talk about the fourth pillar, abstraction. Abstraction is hiding the implementation details and only exposing what is necessary. We achieve this using pure virtual function, which force derived classes to provide their own implementation. In our code, worker is now an abstract class because it has a pure virtual function. This means we cannot create objects of worker directly, and every subclass must implement the rule function. Now, in int main, let's say engineer name is Kim with salary of 9,000. Since worker is an abstract class, we cannot create its object directly. Instead, we assign it a derived class object, which demonstrates polymorphism. So, we ask the user to enter a number. If the user enters 1, we will display the engineer's details and their role. We use switch statement to check the user's input. If they enter 1, we call display method, which prints the engineer's name and the salary, and then the role method, which specifies that this person is an engineer. So you notice that since object is a worker but points to an engineer, polymorphism ensures that the correct role function from engineer is executed, not from worker. After the program executes, we free the dynamically allocated memory using delete object. This prevents memory leaks and ensures that our program manages resources efficiently. By doing this, we properly remove the engineer object from memory when it's no longer needed. And that's all. Thank you.